Welcome to The Explainer. Every great app, every piece of software, it all starts as an idea, right? But how do you get that idea from your brain into a whole team of people's hands so they can actually build it without everything getting lost in translation? Well, today we're looking at the blueprint that makes it all possible.
Here's how we're going to break it down. We'll start with the big communication problem that pretty much every software team runs into. Then we'll dive into 4 essential diagrams that solve it. We'll look at user goals, system structure, and system behavior. And finally, we'll see how all these pieces snap together to take a project from an idea all the way to done.
All right, let's get into it. Before you write a single line of code, you have to have a plan. But making a plan for software is tricky. I mean, how do you create something that a project manager, a developer, and a client can all look at and see the exact same thing? I mean, really think about that. This is the absolute core challenge. Getting everyone on the same page is just notoriously difficult, and a tiny misunderstanding at the beginning, that can snowball into disastrous and very expensive mistakes later on.
The problem is that our normal ways of communicating just don't really work here. If we try to describe the system in plain English, it's way too fuzzy. You say one thing, but everyone hears something slightly different. But if you jump straight into the code, forget it. You're completely lost in the weeds. It's just way too detailed for planning the big picture.
And this is exactly the gap that UML was made to fill. So the Unified Modeling Language, or UML, it's not a programming language. The best way to think of it is as a visual language, a shared set of symbols and diagrams that gives everybody a clear, non-negotiable way to design software. It's the industry standard blueprint.
So where do you even begin with a blueprint like this? Well, you always start from the outside and work your way in. You start with the user. Before we can figure out how we're going to build something, we have to agree on exactly what it needs to do for the people who are actually going to use it.
And for that, use case diagrams are your best friend. They completely ignore all the complicated stuff on the inside and just focus on one thing, the user's goals. You could think of it like a contract. This diagram clearly spells out everything the software promises to deliver to the end user. No ambiguity.
And what's amazing is just how simple the building blocks are. You've got actors. Those are just stick figures representing people or other systems. You've got use cases, their goals, which are just simple ovals. Then you draw a big box around the ovals to define your system boundary, and bam, you've mapped out every key interaction.
Let's make this real with a classic example, an ATM. So you draw a stick figure for the customer. Then you draw lines from that customer to a few ovals, maybe labeled withdraw cash and check balance. Then you'd have another actor, the bank, and it's connected to a use case like update account. It's a super simple but really powerful map of who needs to do what.
Okay, so we've all agreed on what the system does from the outside. Now, we need to peek inside the box. What are the main components? The architectural building blocks that are going to make all that functionality actually happen.
For that job, we turn to class diagrams. So, if use cases are about the system's verbs, what it does, then class diagrams are all about its nouns, the customer, the account, the transaction. They define the solid, static structure of the system. Each class is just shown as a simple box, and it's split into 3 little sections. At the very top, you've got its name. In the middle, you have its attributes, so the data it keeps track of. And at the bottom, you have its operations, the actions it can actually perform. It's a crystal clear summary of what each piece is responsible for.
But here's where the real power comes in. It's not just about the individual boxes. It's about the lines that connect them. This table shows us exactly that. We could draw a line from a customer class to an account class and label it to show that one customer can have many accounts. This structural map is absolutely crucial for the developers who are going to build this thing.
So, we have the user goals and we have the system's static structure. But software isn't static, is it? It's dynamic. It does stuff. So how do all these parts actually work together, moment by moment, to get a task done?
To model this dynamic behavior, UML gives us 2 really powerful tools. You've got sequence diagrams, which show us how objects talk to each other over time. And then you have activity diagrams, which show us the overall step-by-step workflow. Let's take a quick look at each one.
A sequence diagram, it basically tells the story. It zooms in on just one specific scenario, like a successful cash withdrawal, and it shows the step-by-step conversation between all the different parts of the system that make it happen.
The whole diagram reads like a timeline, right from the top to the bottom. Each object in the story gets what's called a lifeline, a vertical line running down the page. And the messages? They're just arrows going back and forth between these lifelines. It is an incredibly intuitive way to see a complex interaction play out.
Let's go back to our ATM.
You'd see the customer lifeline send an insert card message to the ATM lifeline. The ATM would then shoot a verify PIN message over to the bank lifeline. The bank replies, and so on, just step by step by step down the page. There is zero ambiguity about the sequence of events.
Okay, now let's switch gears to our other behavior diagram. If sequence diagrams are all about specific ordered messages, then activity diagrams, well, they're like supercharged flowcharts. They zoom out to show the entire flow of work for a process, from the very beginning to the very end.
And that's why it probably looks so familiar. You've got your actions in rounded rectangles, your decisions in diamonds, but what makes it supercharged is that it can model things happening at the same time, using these things called fork and join nodes, and that is absolutely vital for modern, complex systems.
That whole PIN verification process is a perfect example. After the enter PIN activity, the flow hits that diamond-shaped decision. Is the PIN valid? If yes, the path leads to Show Account menu. If no, the path branches off to Eject Card. It maps out the logic of the workflow perfectly.
So, we've seen 4 very different diagrams, each with its own specific job. You might be wondering, how do these things all connect? Well, the key thing to remember is that they aren't just isolated pictures. They actually form a single connected story that guides the entire development process from start to finish.
You follow a really logical path. You start with use cases to define the what are the user's goals, then you design the structure to support those goals with class diagrams. From there, you model the nitty-gritty behavior with sequence and activity diagrams. Each step builds on the last one, adding more detail and making sure the entire team is building the exact same thing.
So, is a picture really worth 1,000 lines of code? You know, when it comes to building complex software, the answer is a definite, resounding yes. UML really challenges us to think of modeling not as some tedious paperwork, but as an essential, collaborative act of communication. It lets a team agree on the story of the software they're about to build, long before the first, expensive line of code is ever written.